So like I said, for the benefit of those that need it, I'm going to go over some of the recent homework assignments and explain how to do them in case you are having any trouble. So just follow along and this could be beneficial for you, okay? So last week we looked at arc length and sector area after we learned about radians. And we used both degrees and radians to find arc length and sector area, but we remembered that they use different formulas depending on what measurement the angle was given or the arc was given. So remember, if you're given a measurement in degrees, if you're trying to find arc length, you would just multiply the measurement of the angle in degrees over 360 times 2 pi r. If you're given the arc length in radians, you would just take the measure in radians and multiply it by the radius. Okay, guys? So that's how you find arc length, using the two different formulas. To find sector area, if you're given the measure of the arc in degrees, then you just multiply by the measure of the arc in degrees over 360 times pi r squared. And then if you're given the measure of the arc in radians, you would multiply it by 1/2 r squared times the measure of the arc in radians, okay? So those are the formulas that we use, all right? So I'm going to go over, not all of them, but some of the problems from your homework. So follow along if you needed extra assistance. So let's look at number 1. It should be fairly straightforward. It asks us to find the length of arc AB, okay? So if I'm trying to find the length of arc AB, the central angle is given in degrees, so that means the arc is also going to be in degrees, and it's going to be 120 degrees. It'll be the same as the central angle, all right? So that means that we're going to use that formula theta over 360 times 2 pi r. We're basically multiplying the fraction of the circle times the formula for their circumference, okay? So if I want to find the length of arc AB, I would do 120 over 360 times 2 pi, and my radius is 6. So I would just need to simplify all of this. 120 over 360 is 1/3, so that's times 2 pi times 6. And then if I notice the 3 and the 6, I can divide 6 by 3, and that becomes 2. So if I multiply 2 by 2, I get 4 pi centimeters. So that's how you would solve that one. Not too bad. All right, let's look at the next problem here. We've got the diameter is 24 centimeters. Find the length of arc CD. Well, the central angle is given in radians, so the arc would also be in radians. That would be pi over 3, and it tells us that the diameter is 24. Well, if the diameter is 24, then the radius is going to be 1/2 of 24, so our radius would be 12. So the radius would be 12 units long. So we're going to use the formula for radians, and then we're going to plug in 12 for the length of the radius. So remember, all we got to do is multiply. So to find the arc length, it's going to be the measure in radians times the radius. Okay, guys? So the radian is pi over 3. The radius is 12. Okay? So if I simplify this, 12 divided by 3 is going to be 4. So again, I get 4 pi centimeters. Same thing. All right? Let's go on and look at number 3 now. Right? Now it's telling us the length of the arc from here to here is 5 pi inches. And now it's asking us to find the length of the radius. So basically you're using the formula and you're solving for your unknown. You know the length of the arc, okay? And you know the measure of the angle, or the measure of the arc in degrees. Now we got to find the length of the radius, okay? So again, you would, in this case, since it's in degrees, it'd be the theta over 360 times 2 pi r. So in this case, 30 over 360 times 2 pi r equals 5 pi. We're going to set that equal to 5 pi. So now we're just going to do some simplifying here. And then we're going to solve for r. Okay? For one thing, your pi is going to cancel out on both sides. If you got 1 on both sides, it's going to cancel out. All right? I know that 30 times 2 is, so this would be 60 over 360 times the radius equals 5. So 60 over 360 times the radius equals 5. Okay? This gets simplified to r over 6 equals 5. Okay? 60 over 360 simplifies to 1 over 6. The zeros go away. 6 over 36 is 1 over 6. So you could rewrite that as r over 6 equals 5. And then if you multiplied both sides by 6, you'd get r equals 30. So the radius is 30 inches. Okay, that's how you solve that one. Number 4, it's very similar to the one above it, so I'm not going to spend a whole lot of time going over that one. Number 5, I'm going to zoom out on this a little bit. A circle has an arc that measures 4 pi over 9 and whose length is 88 pi. What is the diameter? Well, again, you would use the formula for radians, and then you would find the radius and double it to get the diameter, okay? I will look at number 6 in a little bit more detail. A circle has a circumference whose length is 25 pi. Find the length of an arc whose central angle is 90 degrees. Okay, well, so I know the circumference is 25 pi. So when dealing with arc length, I know that I need to know the radius because I could do the theta over 360 times 2 pi r, okay? So in this case, I can find the length of the radius because if the circumference 2 pi r equals 25 pi, again, my pi's are going to cancel out. And then if I divide both sides by 2, I know that my radius is going to be 12.5 units. Okay? So if I'm trying to find the length of the arc, and again, I know that the central angle is 90, so that'd be the same as the arc. So it'd be 90 over 360 times 2 pi times 12.5. Okay? So again, you're going to have to do a lot of simplification here. So when we simplify all this, 90 over 360 is 1/4 times 2 times 12.5 is 25, and then you got the pi, and then 1/4 of 25 is going to be 6.25. So this ends up being 6.25 pi, and it didn't give us a unit, so we can just leave it like that. There you go. All right, number 7. Very similar to previous problems that we've worked on, so I'm going to trust that you guys can figure that out. If you have further questions about any of these, just let me know.